Hi all, this is the video for the lathes here at MakeHaven. So the lathes are super cool tools. They're sort of fundamentally different from most of the other tools that we use because they hold the workpiece and spin the workpiece, and then you apply a stationary tool to that workpiece. And so that's different from most other saws or the bridge ports or drill press, where normally it's the blade, the tool that's spinning or moving fast, and then the workpiece is relatively stationary and is moving through that. So this sort of flips that around a little bit. What the lathe is used for is for making things that are radially concentric, which is to say things that have features that are consistent around the diameter of the workpiece. Because the workpiece is spinning and you're making modifications along its side as it's spinning, you can't put features on it that aren't consistent around it without stopping and going to a different operation. So first, basic safety, which applies to both of the lathes and frankly most of the tools in the metal shop. Eyeglasses required whenever you are in the metal shop. You need to be safety rated, eye protection, no dangling things, neckties, earbuds, sleeves, jewelry, anything like that. You know, this is spinning incredibly fast. It has a lot of horsepower. So if it were to catch anything on your body, it would be really bad news. So make sure that hair is tied up, anything dangling is sleeves are rolled up, etc. They're buddy tools, so there needs to be someone else in the room when you're operating them. The reason for that is that they are dangerous enough that they could hurt you in such a way you wouldn't be able to help yourself. So for that reason, whenever the tool is running, there needs to be someone else in the room. That said, it's not a buddy tool if you're just doing setup when the tool is off. Because sometimes it'll take half an hour to get a piece lined up and dial it in and get everything really nicely lined up. And as long as the tool is off, that's, you can do that. That's okay. Just make sure to have someone in the room whenever it is running. So now we're going to just compare these two lathes, and then we'll go from one to the other. So lathes are defined in part by the largest swing of the piece that they can hold. So that's the biggest diameter of a piece. So here the distance from this chuck to the ways, to the bed, is about 7 inches. So this is a 14-inch lathe. Over here on the Emco, the smaller one, this one is an 11-inch lathe. So it has an 11-inch swing, 5.5 inches from chuck to the ways. Then in terms of the length, this one has about 2.5 feet, and this one has a max of about 4 feet. Another difference is that this lathe can only be hooked up with chucks. So these chucks have jaws that open in and out for holding onto your workpiece. The Emco, the smaller lathe, can use chucks as well as collets, which we'll review. And collets are more precise than chucks. So in general, if you want to do something fairly precise and it isn't very big, then the Emco is the better lathe to use. So now we're going to go over the anatomy of the lathe. They're fairly similar between the two of them, but I'll point out differences. This is the head stock. So this sort of whole situation is called the head stock. It's at the head of the lathe. It rests on the bed. So here you can see this bed goes the full length, and these are called the ways. The ways are what this carriage slides on. Then down at the other end, we have a tailstock. And then looking at some of the other bells and whistles on here, this is a start button. So once you've scanned into the tool, then you can push the start button to turn it on. This is a brake. So this both turns the tool off as well as physically slows it down and stops it. So here, these are the two controls for high and low gear. So using these, you can tell it whether to be going in the fast gear or the slow gear. This, when the tool is on, tells you how fast you're spinning. And then down here is the variable speed. So the way it works is when the tool is off, not spinning, then you can go from high gear to low gear because you're changing the gears in there. And then when the tool is on, you can change this variable speed. This has a pulley, or 2 pulleys with a belt riding on it, changing size, and it only works when it's spinning. So that's important. This is only when the tool is on, and change these when the tool is off. There's a little note here that we'll go through later explaining how to change the speeds. So take that, go slowly as you're figuring that out, because you don't want to mess that up. We have these 3 knobs and levers, and what they control are these 2 rods. So the bottom one is called the feed rod, and the top one is called the lead screw. The reason to use the lead screw is if you're threading something. So if you are making something you want to have threads in it, then you will engage with the lead screw. If you want to remove material, either going this way when you're turning or doing a facing cut, then you will be using the feed rod. If you're going this direction, it's called the cross feed on the cross slide. So this unit is called the cross slide. It moves this direction across the lathe. And then if you wanted to go this way, to have the lathe move itself automatically this way, then that is called the long feed. You can do both of those manually too. I'm moving the cross slide manually, and then here I'm doing the long feed manually. In this case, the long feed is actually using this gear rack here along the back, which there's a gear that's engaging with that. But if you wanted to do those things automatically, because you want a really nice, consistent cut and finish, then those are the automatic features that use this feed rod. So while we're here, we're going to look at more pieces on the carriage. So we already looked at this. This is going to move us the long way. And then this is the cross slide. And then looking on top of that, we have something called the compound. And so the compound can have, it can change angles. So depending on where you want it, you can change the angle of the compound. And this has its own feed. This can't be automated. This is only by hand. On top of that is a quick change tool post. And we'll look at this later, but you can drop tools right into this and clamp them in place. And that's super convenient. So that you can change tools quickly. There are other kinds of tool posts you can put on here, but the quick change one is what most of our tooling is set up for. Then we'll look at these little pieces of metal. These are the scales for the DRO, or digital readout. So those aren't really things you need to interact with, but they send information up here to the DRO, the digital readout. So on a lathe, the axes are defined a little differently than they are on a mill. But if you think of the headstock here, this chuck, as a spindle, it makes a little more sense. So this is considered the Z-axis, moving this way. So this carriage is moving along the Z-axis right now. And then moving in and out along the cross feed is the X-axis. So this direction is the X-axis. And we can see this reflected in our DRO. So up here, as I'm moving the cross slide, you can see that moving. And then as we move along the long feed, you can see the Z changing. Something interesting to be aware of is that on a lathe, when you are turning a piece of material like this, you're cutting on the front of it, but every time you remove some material from the front, that's also material that's no longer on the back. So when, for example, you progress this cross feed forward by, say, 1/2 inch, the diameter of your workpiece is actually changing by a full inch. So that means here is on these micrometers, which are a little hard to see in the camera, but if we set this to 0, so we'll bring this to 0. A full turn is 0.200 inches. And if you wanted to, let's say we wanted the position here, you could just loosen that knob and spin this to wherever you wanted it. So we'll set it right back to 0 right here. And then lock this in place. And then what we're going to do is go forwards 1 turn, well, maybe 5 turns. So it'll be a full inch of diameter removed. So here we're at about 3 1/4 inches. This is a crude way of measuring, but just to show you how far it's moving forward. And if we move this 5 turns forwards, so 1, 2, 3, 4, 5, and then remeasure, this has actually only gotten us to 3 3/4. It only moved 1/2 inch. Even though here it's removed 1 inch of material. So it's reading out 1 inch, even though it's only moved 1/2 inch. And then we can confirm that up here on the DRO. So the DRO also reads the diameter instead of the radius. So it seems more intuitive in a sense that this would measure the radius, just how much it's moving, but it's actually reading out the diameter. So here if we move this back by, say, 5 turns, we'll zero out the X here. So that's zeroed. And then we'll go 1, 2, 3, 4, 5, and we'll get it right back to 0. And now this is reading 1.0000 inches. So that's, again, reading the diameter. It only actually moved ½ an inch. Along the z-axis, going this way, it's totally normal. There's no weird diameter business. The amount that you move it is the amount that it's removing and indicating that it moved. In terms of the direction of the axes, this way is positive. So going away, you're going positive along the length of it, along the z-axis. And then going this way is negative x, and this way is positive x. Then let's see, down here, this knob controls how these two rods engage with the gears in here. So if you look down here, there are 3 arrows. This top one says cross feed, this says threads, and this says long feed. I admit it's a little hard to see that. Up here we have a little Sharpie mark. So this, whichever one is aligned with that Sharpie mark is the one that's engaged. So cross feed with that arrow up and down, and that's when we're going this direction, is right now up at the Sharpie mark. So if we were to turn it on and engage these threads using this lever, then it would, and then to actually tell it to start, you push this down, then it will move in and out along the cross feed. If you wanted to thread, then you would go up to this up position, and then this is called the half nut up here, which you engage, and then so that half nut, so it's literally half of a nut, would go onto this lead screw, and then it would start engaging for threading purposes. And then let's say we wanted to do the long feed, we would have long feed pointing up to this Sharpie mark, and then again engage using this because it's engaging on that feed rod, and it would move in this direction according to the speed that we set. It's also important to note that the two shouldn't be mixed up. Even though both the lead screw and the feed rod move the carriage in this dimension, you don't want to use one for the other. The feed rod is meant to convey enough power to the carriage to cut off a significant amount of metal, and this lead screw has the accuracy to do the threading. If you mix them up, then you could damage the lead screw. It doesn't have the strength to apply that kind of force, and then it wouldn't be good at threading afterwards. And then if you try to use the feed rod for threading, it will be hard to get it accurate. Then looking at the tailstock down here, the tailstock is useful for a whole bunch of things. In general, you should always use the tailstock if you can. Let's say you're doing a facing cut on the end of your workpiece, well then you can't really have the tailstock here because it would get in the way. But short of that, you want to have the tailstock engaged because that just adds a lot more rigidity to your piece and limits the chances of it flying out, which obviously we don't want. So the different things that we can have in here are, well, there's a few things. So this is called a live center. So this is just a sharp point that goes in the end of your workpiece after you put a little hole in the workpiece for it, and it just spins along with your workpiece to help give it some rigidity. Then this locks this quill from going in and out. So now it's stuck, we can't go in and out. Here we loosen it, and now we can go in and out. Let's say we wanted to swap out this tailstock piece. We go backwards, and then it'll actually pop itself right out, just like that. And now we could go and swap it with something else. The primary other thing you would put in here is a chuck. The chuck could be used to hold a drill bit to drill a hole in your piece, or a center drill for just starting a hole that perhaps this could go in, or a drill bit could go into. When you want to re-engage something in here, you just go out a little bit and then slam it in. Make sure it's clean. Make sure both the inside and outside's clean so it's a nice, good snug fit. It's just working by friction, and then it's in there. This is a lock, so if you want it to be able to move, then you go down and it can slide. And then if you don't want it to move, then you can lock it just like that. On the end here, we also have a micrometer dial if you want to control how much it's moving by. Right there. And then just to cover the last few things on here before we go over to the Emco, here we have the forward reverse switch. So it could stay in off, or in general we just leave it on forwards. Then this knob controls which direction these spin in. So right now it's in neutral. This would spin one way and that would spin the other way. And this guy is also kind of important. This is called the carriage stop. And so you can adjust the position of the carriage stop to make sure that your carriage doesn't hit the headstock, doesn't hit your chuck, because that would obviously be very bad. All right, so over here on the Emco, it's mostly the same with just a few differences. Here's the main power switch. This controls the direction. So right now it's in the off middle position. And then if you look down here, you can see it goes 0, 1, 2 on either side. If you go to the right, it's spinning forwards, which means towards us. And then go to the left, it's spinning away from us, which is backwards. And then those 1, 2 relate to this 1, 2. So 1 is the lower speed, 2 is the faster speed. So that's pretty convenient. Then up here, these also control the speed. So you can see these show the positions of the levers. So right now we're in straight up and to the right, which is this one. So right now we have this is the fastest speed, and the option for number 1 is 1100 RPM, and then number 2 is 2200. So that's quite fast. Then we have this dial. Right now it's in the 0 position, so it's not doing anything. If it's up top here, then the carriage would move either to the left if we were engaging in the long feed, or it would go forwards if we were engaged in the cross feed. Down at the bottom, it would do the opposite, so to the right in the long feed, or go towards us in the cross feed. And last, down here, this is just sort of a different version of the other lathe. So here it shows if we are doing revolution, if we are doing inches per revolution. So in other words, we're talking about doing a turning cut on our material and we want to know how fast it's moving sideways. Then here, let's say we wanted to set it to 4/1000ths of an inch per revolution, then we would go to B2. So here we're in 2. We could change it to other gears if we wanted. I'm also turning the chuck while the machine is off, obviously, so that it lets it engage, and then B over here. So now we're clicked into B. Then if we wanted over here, if we were doing threads, then right now we're set to inches, but you can also change gears in here if you wanted to go to millimeters. If you want to change this to a metric lathe, that's pretty cool. Right now we're just going to talk about inches. But you can see actually there's a little diagram up top saying you would swap this 127 for a 120. So you would flop them around to engage a different gear to change it to metric. But here we're talking about inches. So this is the number of threads in 1 inch, or threads per inch. And here, let's say we wanted to do a 1/4 20, because that's a fairly standard TPI. Then you would go to B4 if we want. So we're already in B, and then we're going to go over to 4, and now we would be doing 20 threads per inch. Here we have the same long feed handle. This is our cross feed handle, our compound handle, and then this will actually engage the feed when we wanted to, if you wanted to do threading. Here, this one's kind of cool. Right now, it's telling us with that side-to-side arrow that it's going to do long feed, and if you pull it out and turn it, then it will do the cross feed. One other addition that this tool has that the other lathe doesn't is coolant. So here we have a button on the wall labeled coolant. You turn it on when the machine is on, and it will spray coolant out of here. It has a little magnetic base, so you can change where it's placed. And then this little squiggly arm, so it'll spray coolant however much you want. This controls the amount of coolant spraying out. Normally you don't need it full tilt. And it's important to make sure that down here in the bottom, this grate isn't full of chips, because then it won't be able to drain, it'll spill out on the floor. So make sure this stays clear of chips so the coolant can drain down back into the bucket at the bottom. If you notice that coolant isn't spraying, it may be because the coolant has evaporated, in which case you can just take a pail of water and refill the coolant in the back. Here we have a little light, which is also wired in, so it'll only turn on when the machine is on. This is also on the other lathe, but this is for threading, and this is just a little thread counter. So this can be helpful when you're doing threading. That's a more advanced threading operation, so maybe that'll be a separate video, or you're welcome to ask your instructor if you want to dive into that. The brake on the other lathe is over here, it's that handle. Here the brake is down this foot bar. So when you're working, you have this your foot on here and push it to turn the tool off, which is kind of a cool feature. Normally, you can just turn the handle though. So let's say it's spinning, and then you just turn it off. The brake is only if you want it to stop fast. So I grabbed these 2 pieces of metal from the scrap area for us to practice with, just because it'll be more fun to see it on a real piece of metal than just me talking hypothetically. So we'll start with the Delta. This is just a bigger chunk of metal, so this is probably mild steel. We are first going to look at this chuck, and then we'll show you how to change the chucks on here. So this is the 4-jaw chuck, and each of these jaws moves independently. So what that means is when you grab the chuck key, so all the accessories live over here. So here everyone has a nice home and a label, so make sure to put it back that way. And most of the tools for the Delta are here, and most for the Emco are over here. So right now we're looking for the Delta 4-jaw chuck. So this is for the 3-jaw, which means this is probably for the 4-jaw. So we'll go try this out. And indeed it fits here. So with the 4-jaw, each of these jaws moves independently. And that can be really good because you can mount a piece in here, and then using an indicator, you can make sure that it's perfectly centered. On the universal jaws, which have 3 jaws moving together, it's a little less accurate because you don't have control over the accuracy, so if it isn't perfect, there's nothing you can do about it. When you turn the key, all 3 move together on those. Also, as a note, on these jaws, they have inside faces, so if you're holding something like this, you go like that, but if you're holding a ring, then you can clamp on these outside faces using at these different steps. So that's what those features are for. Another way of turning is between centers. So let's just sort of review the options on this lathe at any rate. One would be to hold it in the chuck, like that, either a 4-jaw or a 3-jaw chuck. And then you can use the tailstock to keep it centered or to do operations, but you don't have access to this end of it because it's held in the chuck. Also, anytime you take the piece out and put it back in, it's not going to be identical. Or if you wanted to flip it around, it's not going to be identical. So one solution to that is turning between centers. So that means here we have a live center, and you would put what's called a dead center in the headstock. The dead center is like a live center, it just doesn't spin, it's dead instead of being live. And then you would have that here and have the live center on the other end, and then you would attach what's called a dog, so we'll look at that over here. So here's some examples of dogs, and so this would clamp on like that to your workpiece. And then we have a drive dog, which you would attach to the headstock, which is spinning, and it would engage with this. So this would be a little bit closer, and that is how you would in turn give power to the piece. So it's spinning, but it's still between centers. One note is when you're turning between centers, you can't part your piece. So parting is when you cut all the way through to part off a piece, but if you're turning between centers and you part it, the pieces will just go flying away. So it can't do that. So here we're looking at the 4-jaw. To get this all lined up, you would put it in, crank each one down individually, and then I'll grab an indicator from over here. So here's an indicator stand with a magnetic base. And we'll grab an indicator to put onto it. So there's a few ways of mounting the indicator on here. One is using the dovetail. So the dovetail just slides right in there. And then the other is to mount this pin through that hole, or actually through this hole. So, you know, depending on your situation, one might be better than the other. So we'll clamp that in there so it doesn't move on us. Tighten that right back down. Let's say we had our piece mounted in here. We wanted to make sure it was perfectly concentric. You could move this guy over. And I'm just being mindful here that this doesn't hit here. So I'm just coming back a little bit. If you needed to, this just pops off. But it's just nice to protect the lead screw that's underneath there. So I'm just gonna leave that on for now. So come back, over. And we're just gonna, with this magnetic base, it's at minus right now, so not engaged. We'll turn it to plus, so now it's on there. And we can take our indicator and put it right on our workpiece, which is not actually in there, because this kind of takes a while. And then we would turn the piece, so we can put it, take it out of here so it's easier to spin. And then rest it against our workpiece. We can use this screw to push it against there. So we engage it, give a little preload, and say we would set it to like 15 or something on this dial. And as you turn the piece, let's say it was a little high here, then the needle would go up and it would go down on the other side. And you know that you just need to push a little harder on the side that's too high and let go off the side that's too low. So you shift it just to the middle, and then when you spin it, the goal is for that needle to not move, so that it's, it's perfectly centered. So that's how you use the 4-jaw chuck. But we're going to swap over to the 3-jaw chuck so that you can see how to change the chucks. We're going to grab the chuck wrench. So that's this big thing, because these chucks are monsters. Definitely not a bad idea to get help if you're removing this. So there's an arrow in there that says off in that direction. So we're going to grab you. And then we don't want this to spin, so I'm going to put this over, like re-engaged in here. Like that. And I'm going to grab a mallet to help knock this off. Alright, so now it's loose. I'm going to turn this way. And I'm also going to get some cardboard to put underneath here so it doesn't hit the ways. I'm not sure if I mentioned this before, but these ways are incredibly important. Anything that mars the surface, will be reflected in the workpiece, because this is what everything rides on. So if these get damaged, every workpiece gets damaged. So it's important to be protective of those. So I'm going to grab some cardboard to protect this, just in case I were to drop it. Alright, so here we have some cardboard, and I'm going to support it. And I'm going to support it with one arm here as I turn it off. Alright, so now we can pull this off, and I'm going to put it back on the shelf labeled Delta chucks. And then here we have the 3-jaw chuck, which conveniently is somewhat smaller. So, and then as a note, this is called a tapered spindle drive. So you can see it has a taper to it, and then there's this thread that engages on the outside. There's also a key, which you might be able to see it back here. And so it's important that key aligns with the key way in the chuck. So we're going to have it right there. So it's much easier to do this one. The other one, it's very useful to have 2 people. And then this just slides right on. As a note, important to keep those surfaces clean. And slides on there, and then we just tighten it up. Doesn't need to be crazy tight. Put this back. And now we have our 3-jaw universal chuck. So I'm going to swap the keys. This is the Delta 3-jaw chuck key. And then I'm going to put this back. So I put this over here in the slow gear, also called the back gears, because what the back gears do in this case is they make this really hard to turn by hand, which is nice for taking the chucks on and off. But we're going to put it back in the normal gears. So maybe there's a good time to look at this little note here of how to change the gears. So to shift from slow, which is the back gears, to fast direct drive, turn the motor off, so the motor is off, we rotate up, push in, and rotate down lever 2. So rotate up, push in, and rotate down lever 2, and then move lever 1 fully to the right while manually turning the chuck. So there, we're back in fast drive. And then just to show you the reverse, if you want to go to slow, motor off, check, lever 1 fully to the left, rotate up, pull out, and down lever 2. Now we're in slow. Alright, so here, back in fast, and here we have this chuck key. As a note, this is a safety chuck key, which means that it is spring loaded, so you can't accidentally leave this in here. Let's say you were tightening something up, and this was still in here, and you turned it on, this would come flying out, and you would have fewer teeth at the end of the day. So it's important to use these chuck keys that are the safety chuck keys that will spring out, so you can't actually leave it in there by accident. So we're just going to open this up. Something to note here is that you almost never want your stock extending beyond the end of the headstock. So let's say this was 3 times as long and it was sticking way out the back. When this started spinning, the back end could just start pinwheeling around and cause massive destruction. Even though it looks really thick and sturdy, when it starts spinning fast, it can get all kinds of squirrely. So the material can go back in and extend, maybe a few inches out, but if it's going out much farther than that, you'll need to consult with a facilitator to make sure there are safe ways to do it using rests and things to hold the stock or going at really low speeds so that it can't get crazy. So, but this is not that long. It's contained in the machine. So we're going to slide this in here, and then using the key, we can just tighten it right up. So just using this one key, we tightened all 3 of them. Something to note is that both on the 4-jaw and the 3-jaw chucks, the jaws are removable if you wanted to swap them out. Sometimes there are reasons to do that, but they're numbered and they correspond to certain slots, and it's important to make sure they go back in that same slot. So just bear that in mind, that it's not random which slot they go in. Now the first thing we're going to do is use a parting tool to just cut off all this mishmash on the end. Alright, so here we have one tool. So this is the tool holder. This piece clips into the quick change tool post, and then clamped into this tool holder is the tool. So there are lots of different kinds of tools you can put in there. These 4 set screws are what clamp onto that tool, and there's a tool holder, wrench here to tighten down on those. This type of tool is called a parting tool because it makes a thin slit to part off your part. And then it has a carbide insert in it. So this is tightened down on, and we have replacements in the store here at MakeHaven. Here's a different kind of tool. This has what's called a braised carbide. It's a braised carbide tool. So it's a piece of steel, and on that tip they braised on, which is they attached a piece of carbide. And so the benefit of doing that is that you don't have to pay for carbide for this whole thing, but you get it right on that tip. That was a little bit before we had this insert tooling. The insert tooling is a little bit better because you can replace it when it gets dull. Then we have normal high-speed steel tooling, and this is a custom one that someone made. And what you can do with the high-speed steel is grind it to a shape that you want, and then use that as the tool. The high-speed steel is great, but just doesn't stay sharp as long as the carbide. We'll just maybe look at some of the other tools here. So this is a parting tool. This is sort of a generic braised carbide tool. Here's another insert tool that's a fairly useful one. This one has 6 sides that you can use, so 1, 2, 3 corners, and then you can flop it for another 3. We'll look at how to swap those inserts when we get there. Here's another kind of parting tool with just a high-speed steel one. This is to hold a boring bar. So the boring bars actually live on the shelves with a bridge port, but you can clamp this in here and then use this to often to get in the inside of a piece if you want to reach deep inside of a part to make it a larger hole. Here is a threading tool, so it has a little tip that you can use to make threads. This is what's called a knurling tool. So these wheels spin and make a knurled pattern, like a grippy pattern, on the piece of metal you're working with. Back here, you can see some other kinds of tools that we have. So you're welcome to try those. These are center drills, which we'll get to in a minute. Here's the chuck and the chuck key, and here's a dead center if you wanted to turn between centers. For the Emco, there's also this little oiler. So you take the red cap off and can push oil into some of these little oiling holes around the machine. And that should probably be done, maybe once per time when you use the machine. Just lives up here. There's some other tooling up here, as well as the other tool holders down here. And then most of these are carbide, but in these tool holders, you can also put high-speed steel. So in the drawer over here for the water jet, we have a lot of high-speed steel attachments. or tools. So the high-speed steel and braised carbide inserts can be useful for all different kinds of shapes instead of the carbide inserts, which are mostly specific shapes. And the high-speed steel can also be ground to interesting profiles. So if you want some interesting profile, you can grind that on a grinding wheel and then make a shape specific to whatever your need is. The benefit of the carbide is it stays sharp longer and can cut harder materials. And then I'll just point out while we're here, this is another 4-jaw chuck for the Delta with really long jaws if you wanted to hold something that was, you know, that was a good shape for it. So we're going to grab this parting tool and part off our piece. And we're going to have to turn this tool post to be useful to us. So we're going to grab the wrench to turn that. And this wrench conveniently has a bunch of different sizes on it. So it looks like this is one for us. Just loosen that. And we're going to turn it like that. And then tighten. Okay. Now we can drop this tool in. And now we want to part the piece off at a flat 90 degrees, and not at this weird compounded angle. So we're going to grab this wrench again, and we can turn these two nuts. So now we can turn this and get it straightened right up. And if you look closely, you can see a little mark right on there, and we're going to line the 90 degrees right up with that mark, so now we know that it's straight on. All right, so now we're going to tighten it down. Okay, and then we can bring this over here. Come off, and now we need to set the height of the tool. So for the height, we want it to be right at the center line of our piece, of our workpiece, and the height is set using this nut. So we're going to come in a little bit. This piece is hard because it doesn't really have a center right now, so we'll approximate it. It looks like it's right about here, so I'm just going to tighten down on this. And then we can just sort of eyeball it for now. It looks pretty good where it is, so I'm going to tighten down, get this nice and tight, and then we're going to come back and figure out where we're going to part it off. So we can just, part it off right around here. Because this is steel, we're going to use some cutting fluid when we do the cut. We're going to turn the tool on now, so just swiping my card. So the tool is now on. In terms of the feeds and the speeds on a lathe, it's the same as on a Bridgeport in the sense that there are formulas to get the theoretical optimal values, but realistically, you just kind of get a feel for it. You figure out, if it's a harder material, then you want to go slower. Softer, you can go faster. If you hear things chattering, then you should slow down. If you're getting poor surface finish, then slow down or sometimes speed up. So it's a lot of just kind of getting a feel for it. The actual formula is 3.82 times the cutting speed in feet per minute, and then that is a value that you get from the machinist handbook. So you can look in that handbook. The page is bookmarked, or you can just Google it for the material that you're cutting, divided by the diameter of your workpiece, and that'll give you the best RPM. But realistically, you kind of figure it out when you're using carbide inserts like we are here. You often go much faster than you would with high-speed steel. So there's a lot of factors to work with. In general, it's better to start slow than too fast. Too fast is dangerous. Too slow, might just not give you the best results. So right now we're in the fast gear. So we'll see, what kind of RPM that gives us. For this one, we're going to do it manually, so we don't need to worry about any of the feeds. So we're going to leave this in neutral, and we can turn it on. And just as a note, it's in forward here, which in general is where we leave it. So we can see it's at 275 RPM, and that seems fairly comfortable. So I'm going to put some oil on the piece, and we'll cut and see what it looks like. and then feed slowly into the part. If you apply too much pressure, you could break the carbide insert, so there's no rush. You can apply more oil if you think it'll help. And then I'm just going to back out to help the chips clear. Something else to bear in mind, as you get closer to the middle of the piece, the material's moving past the blades slower and slower. So on a really big piece, you're going very fast, but as you get close to the middle, it gets to 0 at the middle. It's not spinning at all relative to your tool. So sometimes you'll need to have a lower RPM at the outside and then increase the RPM as you get closer to the middle. Now, let's say that this was like a delicate piece and you didn't want it just dropping off when you were done. What you could do is, with the tailstock, have like a drill bit in there or something that will go into the end of your piece and catch it when it falls. Because you obviously don't want to stick your hand in there when it's spinning. You could also just put like a little cup underneath there to catch it. And just like that, our part fell off. And if you look at this end, you can see that there's just a teensy little nub in the middle. So I'll come off of it a little bit. And that shows that we did a pretty good job of approximating where the center line is. If you're too low, you won't be able to part it because there'll be a big nub in the middle still connecting it. If you're too high, it'll just rub on the bottom of your tool. Now we can turn that off. And now we're going to show how to use the tailstock. So we can just pull this guy out of the way. And then as I'm going to move this over to the left, just to kind of get it out of the way so our tailstock can come in. Being very mindful that this is not getting near the jaws on the chuck, because we definitely don't want those two things to hit. So after we parted off the piece, now we want to put a little divot in the end of it for live center. So the way that'll work is we back this off. So I'm just going to loosen it and then back this out. Extend it a little bit and pop our chuck in. There's a keyed chuck. Then I grab the center drill. So this is going to drill the center for our live center to go into. And then gonna tighten it up with a chuck key. Slide this guy forwards. And I moved this out of the way, so it's over. We're making sure that our tool does not hit the jaws. And then just pull it back out of the way so that our tailstock can come in. We pull it up. Lock the position here with this handle, and then advance this forward. So because we are now drilling right in the middle, we want this to go faster. So when I turn it on, we're going to increase the speed. So now it's up to about 400 RPM. And then I already did this off camera, but then we just advance the center drill there up until you get just about till the end of the drill. You don't want to go past that. You want to stay within that tapered section, because that tapered section matches this taper on our live center. So now we can swap back to the live center. So I'm going to pull you back. We can take this out. And pop our chuck out. Extend this, slam that in. Now we're going to extend our piece. So we're going to loosen it. And then when we extend it, and then retighten it, you just want to make sure it's very tight, because you really don't want it spinning loose on you. It's really tight. And then the tailstock with the live center goes right in that little hole. And the idea now is that it's much more rigid. It can't deflect as easily. So we're going to tighten that, scooch this forward a little bit, and then tighten this up. So now it's really nicely in there. All right, so now we're going to swap out the tools so that we can do our turning cut. This is facing when you're on the face, and this is turning when you're on the side. We're going to swap out our parting tool for a different kind of tool. Another note is that this tailstock is providing rigidity, but in general, or especially when you're not using the tailstock, you want to minimize the stick out. So how far this is sticking out from the headstock is the stick out, and you want to keep that as short as possible, because the longer it is, the more it'll deflect. And what that means is, let's say it's sticking out this far without the tailstock, and you take a cut and you go in, let's say 10 thousandths. What you'll find is if you come off and then measure it, you actually won't have taken off 10 thousandths because the piece will have pushed away from you a little bit. So you'll only have taken off 8 thousandths. So that's why the rigidity is really important. So you're actually taking off what you think you are. So I'm going to grab this tool, and just because of how our tool or quick change tool post is set up, I want to swap this tool to be facing the other way. So I'll just take that as an opportunity to show you how it works. So we're just going to loosen these 4 set screws. And then we can take this out. And while we're at it, I'll show you how the inserts work. So here we're going to loosen up on this guy using this little key. And then down in here, we're also going to, this is sort of a cam, meaning it's like an eccentric circle. So when we loosen this, it should release the that insert. The reason why this is such a dinky little wrench is because you're not actually supposed to apply that much torque to it. So they don't want to give you a big wrench that you can really hammer on. It's just a little thing. So here, now this is loose, so you can slide this guy right up and off. And you can see that there's 6 cutting faces on this. 1, 2, 3, and then flip it over, 4, 5, 6. So let's say all 6 were worn out, then you would replace it. But we're just going to keep this and put it on a new face. But when you put it on, you want to make sure that this surface is clean, so it's not getting crunched down on chips. So I'm just going to clean that out. All right. And then maybe I'll just grab a rag to clean this off. So this will be nice and clean when we put it back in. So now let's choose, so you can see like this corner's chipped, so we don't want to use that one. That looks a little worn. So maybe let's use this corner because that looks pretty healthy. Slide that on there. And then we're going to move that to the middle. Tighten this guy. And then tighten this guy. Alright, so now it's on there. And we're going to put this back in our tool holder in the other direction. And in general, you just want to minimize the stick out on everything. So you wouldn't want to do that because then it's a long arm that can deflect. You want to keep it nice and tight as you can. If you need to reach really far, then so be it. But if you don't need to, just keep it shorter. It looks like this one is missing that little bolt in the top. So we could grab it, but in this case, since we're doing a turning cut, we're on the outside. If it's up or down a little bit, it doesn't matter so much. When you're parting and going right to the middle, it matters a little more. So we're gonna put this in here, tighten down on that. And now what we're gonna do is use the long feed so that we can get a nice, smooth, consistent cut along that length. So maybe before we even come in contact with that, I'll just demonstrate the 3 modes that this can work in so you can see how they all work. And then we'll demonstrate for real the long cut. So first, I'll turn this on. And now, here we're in forwards, so the machine is spinning this direction. This knob controls the direction that these bars are rotating in. So when we turn it like that, they're spinning this way, away from us, neutral, and then towards us. So I'll turn it back to neutral. Let's say we're going to start with a long feed, because that's what we actually want to do. The long feed is pointed up. So then we're going to engage. And this is a little backwards. This handle, when it's to the left, feeds to the right. When it's to the right, feeds to the left. So we're going to go to the right. We want to go this way. Long feed, go down. Now you can see this handle turning. So it's going nicely on its own this way. So it'll be a nice, consistent finish. Up. Let's say we wanted to do threads. So we're threading this way. We'll be using this lead screw. So we have threads pointed up. We're not using this. Engaging this half nut. Now you can see we're going long. And we can check over here to see how many threads per inch that was. So right now we're in the T and this column, and so that's 20. So that's 20 threads per inch, like you're doing a quarter 20 thread. If you want to do more or less, you just find the threads per inch on that chart that you want to do, and then move the handles. These handles you need to move when the machine is off. Alright, and then the last one is doing the cross feed. So we can change this to cross feed, turn it on, and then engage. And now you can see this handle is moving. So it's coming back. Let's say we wanted to go forwards instead. We would just swap the direction of this, and now it's going forwards. I'm going to turn this off, bring this to the end of our workpiece, and then I'll just bring it in by hand. So if you look closely right at this piece, we want a little bit of an angle backwards if we were doing a facing cut, and an angle backwards if we're doing a turning cut. And the reason for that is you don't want the whole face to be engaged. I mean, maybe sometimes you do, but in general, you want to leave a little negative space there, so you're just cutting with the tip, and you're not engaging that whole face, because then it's just rubbing. You know, it's only really gonna, if you're moving this direction, it's only gonna cut with the tip anyways, so that whole backside would just be rubbing against your material. So there might be a time when you want to cut with that whole edge, but if you're going this way or you're going that way on the face, then you want to have a little negative angle. You can turn the compound to achieve that. So we're gonna come in, and now we want to get it close to the middle, so I'm just gonna loosen this. And that looks to me to be pretty close to center line. What we could do is we could remove the tailstock here and then line it up with our live center to get it closer to exact. All right. So now that looks pretty darn close to me. And again, this doesn't really matter so much if you're above or below a little bit. So we'll jog this back. Bring our tail back in, tighten, and tighten. All right, so there are a few different ways that we could figure out how much depth of cut we're gonna take here. One would be that we would find the zero of the piece. We would do a facing cut right at the face, get to the zero. As soon as we hit the middle, then we zero the X. Then another way of setting the zero is by taking a pair of calipers and measuring it. So here we'll measure what we have, and this says it's 1.2485 inches. So for the sake of this, we'll call it 1.25. And then here we have our piece of shim stock. So we'll touch off of this, and then it's just biting just there. So we know that this is 0.01 inches thick. So we only talk in diameters here, so this is actually 0.02, and then we'll add 0.02 to this, so that's 1.27, and so that's what we'll tell this. So we're just gonna push the X, and then 1.27, enter. Now it knows that's where we're at, and now we can know how much we're taking off. So we're gonna come back to the beginning of the piece, this way, and turn our guy on. And I'm going to slow this down a little bit. That seems a little more comfortable. And now, let's say we want to take off, say, 20 thou in a pass, so that would be 40 off the diameter. So because we set the 0 to the middle, this is going to get 40 smaller. So we're going from 1.22. Here's 1.22. And we'll feed it by hand first just to see how it feels. That's a pretty healthy cut. Given that we're not actually making a part here, I'm just going to go a little bit shallower because we want to leave as much material as we can for the people who actually use this part. So I'm just going to come back to, say, 1.24. You can go over here and figure out how fast you want it to go. So the big number on these charts is showing the threads per inch. The small number is showing how many inches per thread when you're using the feed rod. So let's say that we want to take off a pretty conservative amount. We'll see what something in the middle looks like. So maybe we'll aim for like this 46 number, which is taking off 8.6 thou for each rotation. So we're going to aim for here, and again, sometimes it's useful to turn this. Since I'm putting my hands on it, I'm just going to turn this off. To make this easier to turn, I'm going to put this in neutral. So now we can turn this, and I'm going to move this guy while I'm turning the spindle head. So one of the tricks, in addition to putting it in neutral so you can spin the head, is to push down while you're sliding. So that can help it move. Well, and you also have to be pulling out on this pin. Over here. So we clicked into that pin, and now it's telling us for that 8.6 you want to be in L. So you're going to move over to the L, over and up. And again, just give this a spin and click in there. All right, so make sure to go back to fast drive. All right, so now we're back in fast drive. We've set that, so we're going to turn this guy back on. And turn you on. And then we're going to engage this. So since we want it to go this way, we're going to move the handle this way. And then we're going to go to long feed. So like that. And then engage. And you can see it turning. It's going pretty slowly. So we'll see what it looks like. And I'll keep my hand on here in case it's going too fast. That looks pretty good, and if you get a little closer, you can see the surface looks pretty decent. It's making nice little curly chips coming off. They're not like blue because they're too hot. If you wanted a nicer surface finish, like this was your final surface, what you could do is change this to a slower feed rate. So turn the bar more slowly, and then you'd be taking a smaller cut, which would leave a nicer finish. You can also put some oil on it, which doesn't hurt. All right, so now we've done the turning cut, and let's say you were doing more to this. You could part it off. You could do other features. You could, remove more material. You could locate the features once you zero the Z on there, and then you could flip the piece around. You could do between centers. There's a whole bunch of different things you could do, but in general, you're going to start by putting a clean face on the end, putting a hole for your live center to go in, and then doing an initial turning pass to get a nice smooth surface. Because sometimes when you buy metal, it isn't perfectly cylindrical. You need to do an initial pass to get it nice and clean. So now we're going to hop over to the Emco lathe just to see the collets over there, because that's a little different. So on this lathe, we are going to grab the wrench to remove this collet system. Right now it has the 3-jaw chuck, which is identical to what we were just working on. So this guy is called the Emco chuck block, is what we're looking for. And this is different, it doesn't have that big wrench situation. So we turn it so that if you look here, the line here and the line here is matched up on all three. So 1, 2, 3 are lined up, and now this chuck can come off. And this style is called a cam lock spindle nose because these have these cams on them. So you turn here, and there's these camming features that hold on to your chuck. So that's just sort of a different style. Now let's say we wanted to put the 4-jaw on. you just grab the 4-jaw and put it on the same way this one came off. That's pretty straightforward. But let's say we wanted to do something more interesting and go to the collet situation. Then we're going to grab all these pieces, and then this piece is what the collets go into. So this just gets smacked right into this hole. So just like that. So now that's mounted in there. And now the collets live down here. So these are called 5C collets. That's just the style. And we have all different sizes in here. So this is the piece of stock that I grabbed. We're going to use these calipers to see what collet we should use. Just zeroing it out, wiping the faces. And this says about 11/16. So we'll grab an 11/16 collet, which is right here. And that is indeed a nice fit. Close this up. And the way that these work is, as with all collets, make sure that it's clean, clean. There's a little keyway here, so make sure that aligns with the key inside. Just like that. And now there's a handle on the back side. So this we want to pull out, and then we can turn this, and that is going to engage with our collet. So I'm pushing with my right hand on the front, and then turning this. Here I push this little pin in so that this can spin freely. So now this piece, this is a drawbar that goes all the way through. So maybe I'll just take it out quickly so you can make more sense of that. I'll show you what it looks like unassembled. So here we have this assembly, and we have this collet on the other side, and this threads into here. So first we disengage this from those teeth by pushing this pin. So now this can spin freely. And then, so we tighten onto here. So this pulls it in. And then we engage this, and what we're gonna do is pull on it, and it'll just add a little bit of extra snugging power to pull on this collet and tighten down on our material. So we're gonna take that back out. This slides onto here, and in this hole. This here with this pin. All right, and now we're gonna take our collet again, put this in, and then find that keyway, and then tighten this. So now you can feel like it's not coming out because it's getting pulled in there. And now the trick is you don't want to tighten the collet without material in it. So we're going to put this in there. And now we want, when we're pulling back on this handle, for it to just pop nicely. And right now I can't pull it back, it's too tight. All right, so I'm just holding this so it doesn't spin and loosening up on that. And now when I pull, still not quite, loosen a little more, and that was too much. So we tighten it a little bit, just like that. So I'm just gonna repeat that just so you can make sure to hear that. So over here, it was too tight, you can't pull on it. And then over here, it's too loose, that's not clamping anything. And we're gonna tighten a little more, too loose, too tight, back off a little bit, just there. Now that piece is really nicely in there. It's clamped all the way around. So instead of a chuck just holding on a few points, this is holding all around. And when you make cuts, they'll be very concentric. It'll be very, very accurate. On this lathe, the way to turn it on is first by setting the main power to 1. And then down here, you can select between 0, it's a little hard to see, but 1 and 2 going backwards and 1 and 2 going forwards. Right now, both handles are set to the right, which means that we're in this speed range, the 300, 600. So we'll start at 300 going forwards. And you'll also see that this handle is in the up position right now. So we'll put that back at 0. So now this is spinning at 300 RPM, and we can change it to 600. Then here it says do not change speeds when machine is running. So we will not do that. Put this back to 0. And now if we wanted to move the either in the cross feed or the long feed or threading,
then we would engage this, either that way or going up. So by turning the spindle, you can get it to go up and engage in this direction. So now we'll go forwards again, and you can see here that our screw and bar are both turning. To engage it, let's say we wanted to do threading according to the threading table down here, you would engage just like that, and now we're threading. Turn that off. Let's say we wanted to do the long feed for cutting along a turning cut, then you pull up, bring this handle up, and now we're going forwards. This is going pretty slowly, so it's taking a nice slow cut. And then if you wanted to go and do a cross feed, you turn this upside down just like that, and similarly up, and then this time you pull out and go down. It takes a little wiggling, and now you can see that we are in fact engaging the cross feed. Now if you push the brake down at the bottom like this, it stops it immediately, which is great, especially for emergencies, but it does mean that you need to turn this tool off, and then on to get it to reactivate. So it's like an emergency stop where it completely turns the system off.
Everything else on here is pretty much the same. You know, it has the similar tools up here. It shares the tooling, even if the wrenches are a little different. I went over how all of these bells and whistles work, how they engage, and in class you'll get to practice that. And then one of the most important things is when you're done cleaning up. So there are a few tools for cleaning up. We have a broom and dustpan here for anything that comes out. There are vacuums around the space, there are rags. And it's important, these are precision machines and they're only useful to the next person if they're clean. So make sure to give them a nice clean so that they're looking good for the next person. Any scraps, make sure to throw those out. Make sure to put all the accessories that you took out, make sure to put in the way all the extra wrenches and tools, tool holding, calipers, chuck keys, etc. Make sure to put all that away. And I hope you have fun using the lathes. Thanks for watching.